Hello, my name is Ardi, and this is maybe the first time I'm showing my face in my channel. And the question is calculate Vt for t more than 0 in the circuit, and V is the voltage across this capacitor. So we are asked to find V, and there are two ways to solve this problem. The first one is by using differential equation here at time domain, and the second one is by using Laplace transform. So first we need to, in this Laplace transform solution, we need to transform the circuit into S domain and then use analysis on that one. And my friend from MathSamTube will explain how to solve this problem using differential equation at time domain, and I will explain how to solve this problem using Laplace transform. Okay, let's get to the board.
Hi, today with RD, we are gonna solve the same problem, the circuit problem. I will solve this problem using differential equations. Okay, the problem is the switch was at first was on, so this voltage made this capacitor charged, and the capacitor was charged initially, and this switch is now at time is 0. The t0, the switch is turned off, so we have to solve the voltage on capacitor Vd after time, for positive time, after switch is off. Okay, to solve that we have to know that how much charge is in the capacitor, and for negative time, and we consider it steady, so no current here, and the capacitor is fully charged at initially. So now, because it is charged, fully charged, no current, the charge is steady, so the differentiation of charge is 0, so no current. Current is the differentiation of charge, and this is the simply the point here and here, this. So this is plus and minus, the same voltage with here and the same voltage with here. And the circuit is now can be deformed to and this can be simplified by just capacitor this way. So this is connected in series, so this is 40 ohm, and this is simply 60 ohm, and this is 12 ohm, and this is 24, and there is no current, and we can remove this capacitor part, and the voltage amount is of concern. We want to how much the capacitor is charged, so we need to calculate the resistance. We have to know this resistance connected in parallel, and this is 40 ohm and 1/60 ohm. You will all know this formula, and that means this is 24 ohm. Here the resistance, and 12 ohm, 24 ohm, so totally 36 in series, so 24 means 2/3 of total voltage will take here, so the voltage is, well, 16 volts to initial capacitor, so it is V0 minus, and V0 minus and V0 plus will be the same right after the switch is off. It will be the same, and there is a coil. See, and now switch is off, so the situation is, well, there is 6 ohm and coil and capacitor, now this is 60 ohm and this is 40 ohm in series, and this is 6 ohm, and this can be deformed as, well, these are, now the capacitor is the charge source, electric source, and this is plus and minus with 16 volt initially, so it can be deformed as 6 ohms and 16 and 40, 40 and 60, and, well, coil, oh no, well, the order is not important, but for our case this order will be changed. Well, you can think of the backward way, okay, and this is, we got here, this amount is 24 ohm and this is 6 ohm, and totally we get the, in RLC circuit, this is 30 ohm, and we know that in RLC circuit the voltage is L di dt, the change rate of current, but the current is differential of charge, and R dq dt current, and Q over C, and now there is no other external source, so this is the case, and we know that the resistance is 30, and let us note this way, and this is 3 Henry, so I will omit the SI unit, and Q double prime plus, and 1/27 Faraday, but I will write, this is reciprocal, so 27 is 0, and, well, we can solve this differential equation using Laplace transform or trial solution, but I will solve using trial solution. Let Q is gonna be KT, then the dividing by 3, and this will give you, or combine factor out 3, this is k squared because differentiated twice, and this is 10k, and this will give you 9 e to the kt is 0. And we can factorize this amount. These are k plus 1, k91, k plus 9. So k is minus 1 and minus 9. So what we will get is the charge is, well, exponential minus t, k is minus 1, so, and linear combination of these two, minus 9t. Well, now we can think of that initially the charge was, we would get we can get the charge as capacitor times the voltage. So, and we know initial charge, the capacitor is 1/27 Faraday and 16, so 16 over 27, and this is, if we put t0, then a plus b, and there was no current initially. That was steady state, and there was coal, and other than coal we can think of that, yeah. And the current is differentiating this, and minus a minus 9b is 0. So, and a is minus 9b, and we can substitute minus 8b to get b is minus 27a. And because a is minus 9b, so this will get 3 over, oh no, not a, we divided by a, so this is 2 and this is 2, and we are getting this b, not q, so the answer, final answer, Vt is q over c, and 1 over c is 27 reciprocal, so multiplying 27, we would get 18 exponential minus t minus 2 exponential minus 19. This is the answer.
Thank you to Maths and Tube. I will give the link to his channel in the description. Do not forget to subscribe to his channel. There are interesting videos about engineering mathematics there. And let me get into the point. Okay, as explained before, our circuit will be simplified into this series RLC circuit. So we'll have 30 ohm here, 3 Henry here, and 1 over 27 Farad here. And to do analysis using Laplace transform, we need to transform the component into its counterpart in frequency domain. So if we have inductor, we have an inductor parallel with an current source, with the current source value is I0 over S. But remember that I0 is 0, so this equal to open circuit, so we don't need to add current source here, but we do need to change the value of this inductor. It is not 3 Henry anymore. In frequency domain, it is 3S. So I will put it here, 3S, and the unit is ohm, because in frequency domain, all the components, inductor and capacitor, will behave like resistor, so the unit is ohm. And then this capacitor here, it's equal to a capacitor and voltage source in frequency domain. And remember that we have initial condition here, which is 16, so I will have a voltage source in series with this capacitor. Okay, let's draw that. Maybe let's draw that here. So the value of this voltage source is the initial condition, 16 divided by S. Then we need to change the capacitor value, become 1 over SC, and the C value is 1 over 27, so I will have this as 27 over S. Okay, now I need to do loop analysis here, KVL at this loop, and remember that this loop has the same value of this, so this is the same as I can erase this. Okay, let's clean the board and start the analysis. So we are using KVL at node I. When we start from this 30 ohm resistor, so I will have 30, because it's resistor we multiply it by I, and this inductor is 3S, and in the frequency domain it behaves exactly like resistor, so we just use Ohm's law, so 3S multiplied by I, and then this voltage source. So this voltage source, the current here flowing from positive to negative, so our sign will be positive, and the value is 16 over S, and then plus one more value, which is 27 over S, and we need to multiply it by I, and all of this will equal to 0. The sum of voltage in a loop will equal to 0. Okay, now let's move this 16 over S to the right hand side, and we can take 3I out. We can factorize 3I, so I will have this as 10 plus S, and then plus 9 over S, that will equal to minus 16 over S. Then we can make the denominator the same here, and we can move this 3 to the right hand side, so I will have I, and I will have this as S squared plus 10S from this term, so S squared is from this term and 10S is from this term, plus 9 divided by S, and that will equal to minus 16 over S. Okay, now we can cancel S in each side, so I will have this and this, and so I will have I is equal to minus 16 divided by S squared plus 10S plus 9, and I is a function of S. Okay, now we need to find V, because the question is V. So V can be obtained using Ohm's law, so Vs is actually Is multiplied by the value of this capacitor. So I will have minus 16 divided by S squared plus 10S plus 9, and then I will have this multiplied by 27 over S. I forgot the 3 here. Yeah, okay, let's just do this 3 here, so I will have 3is. So for Vs, I just need to divide this by 3. So this is 3i, so I need to multiply it by 3 here. Okay, now let's do some math here. Okay, this will cancel to 9, and I will have Vs is actually minus 144 divided by s. And now let's factor this into s plus 9 and s plus 1. Okay, we now need to convert this into time domain. Let's clean the board and do that. Okay, now we need to do partial fraction, so I will make this as 3 separate fractions. I will have a over s plus b over s plus 9, and then c over s plus 1. Okay, let's do the calculation. So I will have, for a, I will need to multiply it by s plus 9 and s plus 1. Then for b, I will need to multiply it by s and then s plus 1, and then plus c, that will need to multiply it by s and s plus 9, and all of this will equal to minus 144. Then we can start with the s squared term. So I will have a here, and then I will have b, then I will have c, the squared term, all of them have it, and that will equal to 0. And for s term, we will have this 9s plus s, so I will have 10a, plus for s term of b, I will have b, then s term of c, I will have 9c, and that will all equal to 0. And then for this one, the last one, so I will have 9 multiplied by 1, 9. I have 9a, and b does not have the unit, and c does not have the unit term, and this will equal to minus 144, and this will make the value of a is minus 16, and then we can just plug a into that value. So I will have b plus c is equal to 16, because a is minus 16, and then b plus 9c is actually 160. Okay, now let's just subtract this. So we will have 8 minus 8c is equal to, will equal to minus 144, or c is equal to 18. And because c is 18, that will make b plus c is 16. So I will have b will be minus 2. So I will have, this is not t, this is s. I will have Vs, which is minus 16 here, and then b is minus 2, and c is 18. Okay, now we need to convert this to time domain, but remember that this Vs is only this capacitor. At time domain, the voltage will be this voltage source and the capacitor. So the voltage that we need is actually between this node and this node. So I will need to add 16s of it. So I will have Vs of real capacitor. So we'll have Vs is minus 16 plus S plus minus 2 over S plus 9 plus 18 over S plus 1, and we need to add this voltage source. So I'll have 16 over S, and this term will cancel to each other. And so I will have Vs is equal to this term, and that term we can convert it easily into time domain, which is minus 2e to the minus 9, and then plus 18e to the minus 1 multiplied by t, and this is also t, which is the same as the answer from differential equations.
That's all for today. Thanks for listening.